So really glad to be here. First time in Israel. It's been really fun. And excited to talk to you about Gatsby and web performance. So so this talk's going to be some about Gatsby, mostly though about just web performance in general, but also kind of as a way of explaining web performance, explaining why Gatsby works so fast out of the box. If you haven't seen Gatsby, this is the website. You can go check it out while I'm talking if you want more context, because I'm not going to go too deep again into Gatsby. So Gatsby is a modern website framework for react.js designed for blazing fast performance. And its origin story was not a chemical vat or anything like that, a nuclear explosion. It was actually, so back in 2014, I started using React to build a web app for my startup that I was working on. And when it came to time to build a website for us, I was completely in love with React and Webpack. They were kind of new then and had a lot more rough edges, but still really nice once you got them going. And I wanted to use the same stack for our website. And I was like, I'd already used static sites in the past, and so I was like, how do I make a static site generator but using React and Webpack? And so I figured that out, and out came Gatsby. So I open sourced that in mid-2015, and then a year later, my startup kind of died. And so I started working full-time on Gatsby because I had a whole bunch of ideas I wanted to implement. And then Gatsby 1.0 was released a month ago, and I'm currently creating a Gatsby products and services startup. Bit TBD on there, but coming along. Cool. So it's grown a ton. It's always fun to see something you work on take off, because most stuff doesn't. But this one definitely has. So it's got 13,000 stars and growing. We're up to like 165,000 or so downloads a month. Quite a few contributors. Actually, 100 of those, well, about 90 contributors just in the last month and a half alone since the 1.0 release. So it's been a lot of excitement. And I've always been really kind of obsessed with website speed. It's just kind of like, I don't know, for many engineers, perhaps me included, like numbers, anything you put numbers on and optimize against is like turns into a really fun game. You can just like, ooh, now it's 10% faster. And anyways, so Gatsby's been really fun for that kind of optimizing part of my brain, because I've been able to do a lot of fun, experiments about how to like make websites really, really fast automatically. So why is site speed so important? Seems like a fairly obvious thing to most people, but just so we're covering our bases. Users, when they load a website, they want it there and not there. People leave your site if it doesn't load. That's pretty simple. Actually, numbers show that it's actually pretty high. So 53% of mobile site visits are abandoned if pages take longer than 3 seconds to load, which, as I'll show later, there are many, many websites that do not load in 3 seconds on mobile. So it's like super important. Also, the same study compared different types of sites, and there's significant difference in ad viewability, average sessions, lower bounce rates. So for people here who care about making money, all those have very strong. And just in general, it's a crappy user experience. If your site is slow, if it's janky, if you touch things and it doesn't respond, all these things are bad and should be avoided. So the question is, how do you think, what's a good way to think about and measure performance? So I'm assuming all of you here are React engineers, and you have one or many applications you're working on. So you go home from this talk, and how are you going to make your application faster? And how do you think about the problem? Because whenever you approach a problem, you first need to have a good way to think about the problem before you can then solve the problem. And I would say there's kind of two main metrics, kind of ideas around website performance that you should pay attention to. And these are speed index and time to interactive. So we'll go through both of these in turn. And I'd also suggest as your best tool, your best friend in website performance, is webpagetest.org. I've used this gazillions of times, and it's this amazing resource. It's completely free. It's like this network engineer in Virginia, United States, who this is like his hobby, I guess. And he has apparently, like someone I know knows him and has like he says anyways, he has like a whole rack of, phones and other devices and network emulation equipment in his basement. But anyways, whatever drives him, we all benefit because it's a really amazing resource that you can use. And so anyway, so go there and test your site using their simple testing options. There's also Lighthouse Audit, which Chrome recently added to their DevTools under the audit section, which is good, but it's more high level. Web page test is much more actionable. It gives you a lot more kind of like details about what's happening. So Lighthouse Audit, it gives you a nice score, so you can like take that to your manager and say, hey, we got a really bad score on the Lighthouse Audit, and then you actually go to web page test and then use that to figure out how to make things faster. Anyway, so this is the website. It's pretty simple. Go simple testing, put in your site, click start test. So let's talk about speed index, the two metrics that I mentioned. So speed index, or the longer, fancier name, perceptual speed index, is a page load performance metric that shows you how quickly the contents of a page are visibly populated, which is a bit of a mouthful. But let's jump into some examples. So this is the result of a web page test on CNN.com, and that big fat blue arrow is pointing at the speed index for the first view. So web page test, you can set it up so that it does two runs, basically, where it'll load the site, and then it'll actually like close the browser down, open the browser again, and then load it again. So to test what it'd be like with a cache, but not like a hot cache. So it's like just pulled off the disk. Anyways, so on CNN.com, the first view is a speed index of 8,098, and then the repeat view is 6,178. And these correlate to like milliseconds. So it's roughly saying 8 seconds and 6 seconds. And then underneath there, you can see, I forget what they're called. Anyways, it's like every half second, it's a screenshot of the site as it loads. So you can't really see the times, but around the first time that has pixels on the screen is at 6.5 seconds. And then you really start to see something at 8.5 seconds. And then at 10 seconds, it's visually complete. And so the 8 seconds is kind of, averages that out, as we can see. And so this is the actual visual progress. So, again, at 6.5 seconds, it jumps up to 25%, and then it kind of like, stalls for a few seconds, and then jumps up sharply again, and then, ekes its way up. So 8 second speed index. You can see this chart. And this is not a great score, but it's fairly normal. So the next site is Downy.com, everyone's favorite. So for them, they're a bit faster. They're 5,568. And you can see down here, they first pop on the screen in like 3 seconds, and then are actually fairly visually complete at 3.5 seconds. Then for some reason, the navigation menu below drops out at 5.5 seconds. But anyways, which actually, so yeah, you can see that here, where it jumps up almost complete to 80% or so visually complete, then dips down again, dips back up again, and then at 16 seconds actually completes. So clearly they're sitting around loading something or another for a long time. WashingtonPost.com. So this one's somewhere in between the last two ones, 7,650. And we jump over here, and they're kind of bouncing around again, which probably indicates different things arriving and adding or removing stuff from the screen. But anyways, then they pop up around 18 seconds to fully visually complete. And then, hey, GatsbyJS. I've heard of them. Whoa, so fast. 2,300. So that's like 2 to 3.5x or whatever, faster than the other ones. You see down here that 2.5 seconds get the first pixels, and then a half second later it's done. So no forever bouncing around. It's sort of there, sort of not there, which is not an impressive looking thing for a website. Yeah, so that was speed index. Speed index is a super useful score. It kind of gives you a nice high level summary of how fast your site is loading. And it's great and easy thing to optimize, and it correlates very strongly with users' the perceived performance of your site. If you can drop the speed index, then people will think your site's faster. So time to interactive is the silent killer. So it's kind of like blood pressure, I think, where that came from. Anyways, it's not really something that's noticeable, because you can have a very slow time to interactive and everything looks fine. But underneath the hood, the site isn't moving. You can't scroll. You try to click on form elements, and you can't type anything, etc. So the first interactive measure is when a page is minimally interactive user input. So before this, scrolling is janky, typing in forms and other inactivity is hard. So Washington Post that we looked at earlier, it takes 33 seconds on a smartphone on 3G to reach interactivity, which is, I don't know, it's like half your life almost. Anyways, yeah, it's just a terrible experience. I mean, the site feels terrible, which is why all of them tell you to go native apps, because I think they just gave up on their website or something. But it's not actually necessary. As we'll talk about further, you can have much better GTI. So improving performance. So now you have some you go to your site, you can do a test on webpagetest.org, and then you have some high-level metrics describing how your site's doing. Now, how do you make it faster? So first thing is focusing on speed index by optimizing for the critical rendering path. So the critical rendering path is basically the path from initiating loading a site all the way up to when pixels get on the screen. And optimizing for that is basically so again, web page test has a nice, you can look at every network request, everything that's requested on your site, and you can ask yourself, is this thing necessary? Does this need to be loaded in order for something to be painted on the screen? And if it's not necessary, then you delay it, or perhaps get rid of it, because somebody added it 2 years ago, and then nobody noticed that it was loading millions and millions of times pointlessly. So either you delay it, or you possibly can get rid of it. And every time you get rid of one of these requests, which is loading CSS or JavaScript or images, then your speed index will go up, because the network pipe, there's more capacity to pull in the actual critical bytes, and your poor little CPU on your user's devices has to do less work and can just focus on getting to the goal, which is pixels on the screen. Another thing you can do is progressive rendering, because even if your site isn't fully loaded, just the fact that something's happening, to users, then they perceive it as it's faster. And so there's a lot of whenever you read performance stuff, you'll see a lot of things saying talking about blocking requests. So basically, you want to avoid anything that's blocking. So kind of the no-nos are CSS. You don't want to load, not CSS. You don't want to load JavaScript in the head. You want to delay loading JavaScript until the bottom of body. You want to have. Anyways, this talk isn't there's lots of checklists for what to do. But anyways, the point is aim towards progressive rendering, and your speed index, which is a good representation of the perceived performance of your site, will go up. So that's kind of speed index. So eliminate unnecessary loading work that doesn't need to be done. Also make it progressive. And then for improving the time to interactive score, the main thing you can do here is basically load less JavaScript. So similar to the critical rendering path, you can think about what is the critical JavaScript? What is the actual JavaScript that's necessary for the page that's being loaded? And so whenever possible, you don't load JavaScript that doesn't need to be run. And like I said there, in parentheses, this is a whole talk by itself. It can get quite complicated, but if you're using Webpack, congratulations, you're kind of a long ways there. Webpack has a ton of really great ideas and tools around implementing code splitting, so like figuring out automatically which code is necessary for a given page. So there's tons of resources about that online. So anyways, that's what you do there. Yeah. So why is Gatsby so fast? So Gatsby sites, as we saw earlier, consistently 2-3x faster than similar types of sites. And the reason basically is performance isn't optional, it's built in. It makes performance optimizations automatically for your site. It's not a exercise that's left to everyone. By using Gatsby, it just sort of happens. So the basic contract between Gatsby and the user is you give Gatsby React components, and then Gatsby compiles an optimized site. Gatsby does a lot of kind of automatic optimizations. So it inlines critical CSS. It does link preload for critical resources, which is a kind of a newish browser technology where you can indicate that a resource is needed further down the page. Because browsers don't always know if something's needed or not, and so you can be smart and tell the browser hey, I really am going to need this. It also does automatically per route code and data splitting. And also interestingly, once you load a page, it's not just the initial page load that you care about, but it's also clicking onto the next one. And Gatsby also figures out automatically what resources are needed for pages you might be clicking on, and it'll start fetching those in the background once you've loaded a page, so that as soon as you click on the next one, odds are the resources are already there, and it's near instantaneous to jump to the next page. So when we build software, we are embedding decisions in it. There's kind of the split between decisions that we embed in our software and then decisions that we enable our users to make using the software. And when you're designing software, that's a really important kind of architectural decision, or user experience decision is, what decisions are you going to make and what decision is the user going to make. And so when I was designing Gatsby, I decided that basically you don't have a choice about performance, that Gatsby is going to take care of that, and that it'd be really, really hard to build a slow site with Gatsby. And if you've heard a lot of the Facebook engineers, they talk about this pit of success, that you just kind of fall into the pit of success, which sounds unpleasant actually. Maybe it's got cushioning at the bottom or something. So when you fall there, you just give it a drink and you have a bed or something. I don't know. Anyways, so yes, you don't have to think about performance with Gatsby. It just works. The GatsbyJS.org, it doesn't have any optimization special things or whatever. It's just kind of vanilla Gatsby. But there is trade-offs. So when you, with adding something to a framework, like performance optimizations that are added to Gatsby. So it makes framework and sites built with the framework harder to understand. So the more a framework does, the more complicated it feels to build stuff with it. And also actually building the framework is harder because there's more complexity there. And also potentially limits its use cases. So something that's very small and unopinionated can be used successfully in lots of places. And then the more opinionated it becomes, potentially it can do less or be useful in less areas. So something has to be really valuable to add it to a framework versus leaving it to users. So why design performance into a website framework? Basically, I think the history of performance on the web has proven that, it's really hard to get right. So I just Googled like front-end performance checklist, and there's just like a really long list of things you have to do to make your website fast, and it's kind of silly. If you're just doing only like really complicated websites even have the budget to worry about these things, and then even then, as we saw, they're not really getting things right. And also, performance is a moving target. Browsers are moving really aggressively to kind of upgrade the web platform. So like the link preload thing I talked about, service workers, which is like 20 talks by itself. HTTP2 push, again, like at least 5 talks or whatever. Anyways, Babel Webpack, are upgrading and adding all sorts of optimizations. There's all sorts of like code splitting strategies, client preloading, WebAssembly, shared array buffers, on and on and on. So these are, again, really complicated. There's a lot of like, anyways, sometimes stuff is better left to a framework. And as I was saying, huge sites regularly get performance problems. So Sam Saccone, he's a Google engineer, and he kind of has a hobby of writing performance reviews for sites. And they're super interesting and educational. So if you like pop to his website, follow him on Twitter, he kind of like frequently will like dive into some website and and write up a performance analysis. And so Gatsby, kind of how I think about it is, it's an early example of a website compiler. So just like C, C++, other languages have had forever, where you're like targeting different architectures and you like give it source code and it spits out compiled code that's optimized for a particular architecture. Gatsby, you give it your source code for a website, and it compiles the most performant website possible. And so just like compilers are adding optimizations, they figure out new tricks, whatever, to make common patterns faster. Gatsby is already getting faster and smaller. And a year from now, there'll be all sorts of like interesting optimizations that we figured out that'll make things smaller and faster than they are now. And if compiler is kind of like a newish idea to you, you're already using several compilers probably. Babel is a compiler. Webpack is like sort of a compiler, more or less a compiler, whatever. Most CSS is run through compilers and so forth. So it's already like a big part of our web stack. And I think of Gatsby as just kind of like a higher level abstraction compiler, whatever, where it kind of, it kind of like optimizes the whole site and like the runtime and loading of resources and on and on. Yeah. So a few days ago, Tom Dale, one of the major Ember people, he conveniently wrote this blog post that was a lot. It kind of hit a lot of themes I want to talk about this in the talk, and quote a bit from it. So he said, when it comes to eking performance out of hand-authored JavaScript and accompanying runtime libraries, we've reached the point of diminishing returns. Increasingly, the bytes that are shipped to browsers will bear less and less resemblance to the source code that web developers write. The assets we serve to users will be aggressively optimized output of sophisticated build tools. And this is a loss in some ways, as now the output is fairly opaque, but it's a huge win for users, particularly in emerging markets. And our job now is figuring out how to adapt the ideas of high-performance native code while preserving what makes the web great. So, conclusion is, performance is hard. There are easy wins, but as a Gatsby proponent, anyways, I'd suggest trying out Gatsby for your next site/app, and just get a lot of performance wins for free. And also, the more contributors we have, looking at different, optimizations, kind of the more everyone using Gatsby wins. And that's it.